right, so now we will solve this old exams question. So we said if the augmented matrix of this linear system, so this represents an augmented matrix, so it means I can put a line here. All right. So we want to find the value of x that will make the system inconsistent. And I already discussed it. If you want to have inconsistent, it means your last row should be something like this. Inconsistent means there is no what? No solution. So it means you want everything to be 0, right? But you don't want the right-hand side to be 0. So everything in the constant matrix. So it means you like this to be 0, right? But this one, you don't want it to be what? You don't want this one to be 0, okay? But first of all, you have to look at your matrix. Your matrix, can you transform it to an echelon form or is already in an echelon form? You see here is already what? 1. This is 0. So in the real sense, we have to make this to be what? This to be 1. But it's not a problem. We can easily make it 1, but we don't know what is x. So, but if you look at the last row is already makes sense. The last row is already 0. You can see the last row is 0, 0, and what? So we need to know that this has to be what? 0. So it means that we will try to so this is what we want now. This one here should go to a 0, and this one here should not be what? 0. So let's see, it means we have 4x squared minus 1. This should go to 0, and what? X minus half should not go to 0. Now, what does this mean? This means that 4x squared is equals to 1. So x squared is equals to 1 over 4, right? And that means x is plus minus half. And here, x should not be what? Should not be 1 over 2, right? So what does this mean? This simply means that this x, you have two values of x here. Just look at it here. It's similar to what I just did. So x is half minus half, but you have a condition that x should not be equals to what? 1 over 2. So if the x you have is half or minus half, but there has a condition that x cannot be what? Half, then it means the only x that is left is what? Is this one. So it means that your x is just going to be minus half. So this means that if x is minus half, this system is going to be what? Inconsistent. Because if you put minus half here, substitute minus half into this one is going to be 0, right? Here is going to be 0. But here, if you substitute minus half into this term, it's going to be minus half, which is minus. It's going to be minus what? It's just going to be minus 1. So our answer is this one. So anytime you are asked for inconsistent or no solution, this is the same thing as inconsistent. This is what you should be targeting. Your last row, you want all to be 0, but the right-hand side should not be what? 0. Okay, so look at this one again. It says, if the augmented matrix, this, it said, which of the following is false? Now, it has a lot of things. We have inconsistent, unique. So let's try to deal with all of the cases. Now, already you see this is our matrix, this one. This is 1, 0, this is 1. So here should be what? Here is 2, here is c squared, here is 8. So if you want to convert it to echelon, you can do it. You can convert it to echelon first. So you can do one step because all these are numbers. So let's say this is 1. Let's take this guy to what? To 0. If you take this guy to 0, you will have 2. To take this guy to 0, it's going to be minus 2R2. Yeah, plus what? Plus R3. So this is going to be, this is still 1, 2, 3, 4. This is going to be 0, 1, C squared. Here you will have 0, 0, minus 2R2. So you have minus 2R2. So it's going to be minus 2C2. So you have minus 2C squared plus what? Plus 8. Then this side, which is the last term, this is still 1. It's going to be minus 2 plus what? Plus C. So you have something like this. This is what we have. So now let's see inconsistency. When do we going to have inconsistency? So inconsistency means this is our last row, right? So we take note of this last row. So if we want inconsistency, and remember, what is inconsistency? It means there is no solution. For inconsistency, you want 0, 0 everywhere, but here you don't want it to be 0. So let's start with that. This is inconsistent. Remember, inconsistent means there is no solution, right? So we will see whether it is true. So it means that you want this guy, which is minus 2C squared plus 8. You want it to be 0. And the right-hand side, which is minus 2 plus C, you don't want it to be 0. This is what it is. So it means that here you can solve this. So this is going to be 2C squared. It's equals to 8. Yes. So C squared is equals to 4. So C is what? Plus minus 2. But you have this and. Here, C cannot be what? Cannot be 2. Yes or no? Cannot be 2. So here you have C cannot be, no, sorry, C cannot be 2, yes. You have C cannot be 2. And here you have C is what? Plus or minus 2. You get that? So which one is going to be correct? It means C has to be what? Minus 2. So it means that the system is what? Is inconsistent when C is equals to what? Minus 2. So this is true. But if you look here, the system is inconsistent for C equals to what? Minus 2. So this guy is what? Is true. Right? It's true. Okay? But remember, we are not looking for the statement that is true. We are looking for the statement that is what? Is false. So if this is true, then definitely this one is going to be false. The system is inconsistent for all C not equal. This is not true because we can see that C the system is inconsistent if the what? If your C is what? Is minus 2. Okay. Now let's even do it for all. Let's see now so that we can check everything. Now we've done inconsistent. Remember I say inconsistent means no solution, right? So let's see. Since we have another one here is what? Let's check this C. Is it true or false? This C, when the system has a what? Unique what? Unique solution, right? Now, so let's check unique solution here. So unique solution. Now for unique solution, which is the same thing as one solution, all you need to check is that the last row of your matrix, your echelon form, has to be this last guy. That should not be what? Should not be 0. That is the most important thing. The most important thing is the last entry should not be 0. That is the entry in the third column. Should not be 0. Okay, so okay, so let's see what's wrong with the pen here. Okay, let me write it again. So you have 0, 0. The last third should not be 0. Then the right-hand side can be anything. You don't really care. So for what unique solution, all you are after is that what? The last entry here should not be in the third column. Should not be 0. So it means that what? It means that you have to go back to our matrix. The echelon form is this one. So this is the row echelon form. So it means that what is the element? This element here, which is minus 2c squared plus 8, should not be what? Should not be 0. That is the only thing we care. So it means that what? It means that 2c squared should not be what? 8. And this means that c squared should not be 4. So c should not be plus minus 2. Right? Should not be plus minus 2. And you can see that this is true. So you can see this is still true because the system has a unique solution for all c not equals to what? Plus minus 2. This is a true statement. Okay. But remember, we're interested in the one that is false. Okay. Now let's see. D. The system has infinitely many solutions for c is equals to 2. Now, how do you check infinitely many solution? For infinitely many solution, you need to have something like this. Everything has to be 0, right? The third row has to be 0. So it means that you need to have 0. Here is 0, 0, but this has to be 0. So it means that minus 2c squared plus 8 should be 0. And not just that, the right-hand side also has to be 0. What is the right-hand side here? The right-hand side here, you can see is just this one, which is minus 2 plus c. So minus 2 plus c also has to be what? 0. And here, this means that what? C squared is equals to 4, right? So it means c is plus minus 2. And here means that c is equals to what? C is equals to 2. So if you take the intersection of this, it means that what? Because there is and c, it means that c has to be equals to what? 2. So, and this is true because the system has infinitely many solutions for c is equals to 2. This is also true. Now, what about E? Is E true? The system can be made consistent or inconsistent for any suitable value of C. Yes. You can make the system consistent, or consistent means what? It has at least one solution, or you can make it inconsistent depending on the value of C that you choose. Yes, this is also true. So for example, if you choose C to be any number which is not minus 2 or 2, you're going to have unique solution, which is consistent. If you choose C to be -2 is going to be inconsistent. So this statement is true. So the only statement that is false is this one here. Why is it false? Because it said the system is inconsistent for all values of C not equals to -2. And what is inconsistent? But inconsistent, where do we have inconsistent? Which is this one. Inconsistent is only when C is equals to -2. But this is saying for C not equal. So get the difference. All right, very good. So let's see now this one. Now number 3. Number 3 says that what? If the augmented matrix is written in the echelon form. So what it simply means is that you should convert this matrix to echelon form and then get what is K, M, and N, and then you add. So if you look at this, you will realize that this is 1 here. So this has to go to 0. This has to go to 0, and this also has to go to 0, right? So what type of operation do we need? Remember, we need echelon form, not reduced echelon. So it means we can apply, this is going to be fixed, row 1 is going to be fixed. So we can apply the additive inverse, so -3R what? R1 plus R2, and then -2 R1 plus R3. So if we do that, this is going to be 0. Let's finish with the one in row 2 first. So -3 times -1 times 1 is -3. -3 plus 4 is going to be 1. -3 times 1 is -3. -3 minus 1, -4. -3 times 1 is -3. -3 plus 13 is going to be 10. Okay. Then what next is the second row, all right? So we have -2. So -2 times this is going to be 0 here. -2 times 1 is -2. -2 plus 2, this becomes also 0. -2 times 1 is -2. -2 plus 0 is still -2 here. Then -2 times 1 is -2. -2 plus 6 is 4, right? So you see that it's coming out little by little. This is 1 here. This is also 1 here, all right? So the next thing is just to convert, I think, this one to what? To 1. So this has to go to 1. Right. Okay, so this one here, this is 1 and 1. So now we have to take away this one. But now, what can we do? We can just divide. So this is -12 R3. So this is going to be 0, 0, 1. And we're dividing by half. So this is going to be -2. And every other thing here is 0, 1, -4. Is it 10? And here it is 1, 1, 1, 1. So looking at this, I think it's already in an echelon form. So this is what? Is an echelon form or row echelon. Yeah, because row echelon. Yeah. So we now need to compare it with what you have. We want to reduce it to something like this. So compare this and this one. So you can see that these are the values that we need here. This is the position of K. This is the position of M. And this is the position of N. So you can say that K, we can deduce that K is -4. M is what? 10. And N is what? Is it -2? And so if you add all of them together, K plus M plus N, it's -4 plus 10 plus -2. And this is just going to be 4. So, okay, this question asks us to find the solution. So we'll attempt to use Gauss-Jordan or Gaussian elimination. So we will put this in to augmented matrix 1, and this is 2 minus 5 minus 3 2 1 4 1 1. So you have to be very careful, because if you miss one term, then you'll be dealing with a wrong matrix. So this now we have to take this to 0 and this to 0. So we can apply -2 R1 plus R2 and then minus R1 plus R3. Applying that, this will still remain as 1 minus 3, 1, and 8. So this is for R2. So let's go up a little, because R1 remains the same. So here, what do we have? This is going to be 0. -2 R1 is -2 times -3, which is 6. Then 6 plus -5, this is going to be 1. Then you have -2 times -2 times 1 is -2. -2 minus 3, this is -5. -2 times 8 is -16. -16 plus 2, this is -14. Then now we do minus R1 plus R3. So this will be 0. Minus this will be 4. No, 3 plus 4, this is 7. -1 plus 1, this is 0. Right. And then -8 plus 1, this is -7. Okay, so what next? We can take this one to 1. And we can use 1/7 R3. Do we need to take this one to 1? No, we need to take it to actually 0, because this is 1, 0. This is already 1. So this has to go to 0. And that we can use -7 R2, right? Because right now we will fix R1 is still the same. R2 is also the same. So we just need to take this guy to 0. So let's put this guy to 0. Now we have put this, so take this guy to 0. And to do that, remember, it's appeared in which column? It appeared in row 3. So row 3 and column 2. So let's write it here. It's going to be -7 R2 plus what? R3. This will be 0. And this is going to be 0 as well, right? So here now you'll have -7. So I think it's going to be -7 times -5. is going to be 35. So 35 plus 0 is still going to be 35 here. Whoop. Now we have minus 7 times R2. So this is minus 7 times minus 14. Right. So which will be around 98. Is it? Yep. So you have minus 7 times minus 14 is going to be 98. Then you have to remove 7, which should be around 90, 91. Okay. So I think we can stop here. So what does this mean? We can take this to, we can decide to take this to 1, actually. We can decide to take this to 1. And how can we do that? We can say 1 over 35 R what? R3. So this is 1 minus 3, 1, 8. This is 0, this is 1, this is minus 5, minus 14. And this will become 0, 0, 1. And here will be 91 over 35. So this is actually what we have now in what's in row echelon form. So this is row echelon form. And now you can see that we have our pivot entries, this, and this. So here, we're stopping here because we want to use Gaussian elimination. So by Gaussian elimination, so we're using Gaussian elimination. So for Gaussian elimination, it means that Z is equals to what? 91 over 35. And this one, can we break it down a little? Yes, I think we can break it with 7. This is going to be 13 over 5. And now if you go back, this is coming from row what? Row 3. Now you will also see that you have y minus 5z is equals to minus 14. This is coming from row 2. So this is going to be y minus 5 times z, which is 13 over 5, is equals to minus 14. And then you have y minus 13 is equals to minus 14. So y is just going to be minus 14 plus 13, which is equals to minus 1. So this is y is equals to minus 1. Z is this one. Then you go back to the first row, you will see that you have x minus 3y plus z is equals to 8. This is coming from row 1. And now this is x minus 3 minus 1 plus z, which is 13 over 5, all is equals to 8. So this is x plus 3 plus 13 over 5. It's equals to 8. Now this, we can write everything as over 5. So this is x plus what? 15 over 5 plus 13 over 5. And even this one, we can just write it as 14 over 5. And this x is going to be what? So you will see that x is, this will be x plus 28 over 5, right? 28, yes. So x is going to be 14 over 5 minus 28 over 5, which is 12 over 5. So we have our x, we have our y, and we have our z. And you can see that this has a unique solution. So the solution, x solution set, x, y, z, it's simply 12 over 5. And the y is minus 1, and z is 13 over 5. Don't forget, here we used Gaussian elimination. So we have to do what? We have to do back substitution, right? So now you want to find a plus b. So this is our a, this is our b, and this is our c, based on the question, because the question says a, b, c is the solution. Now to find a plus b plus c, you just need to add the solution. So let's say a plus b plus c is just 12 over 5 plus minus 1 plus 13 over 5. And this is going to be 12 over 5 minus 5 over 5 plus 13 over 5. Right? And what do you have? You have 12 minus 5, which is a 7. 7 plus 13 is going to be 20. So this is 20 over 5, which is just 4. All right. Okay, so let's try to solve the last one here. The last one is saying if you have u, v, w to be the solution. So this, in this case, let's try to use Gauss-Jordan. So this will be 1, 0, y is 0, so it is 1, 0, minus 1. And then on the right-hand side, we should have minus 3. Here should be 0, y is 1, z is 1. The right-hand side is 9. Here x is 1, y is 0, z is 1. And here is 7. So this is the augmented matrix. Now, we have to take this to 0. So this will be minus R1 plus R3. Now, let me use this. So this is minus R1 plus R3. This is 1 here. Okay. So this, remember, 1, 0, minus 1, minus 3. This is still 0, 1, 1, 9. Okay, and this is going to be 0 because I'm doing minus 1 times R1. This is still 0. And what is the next one? Minus 1. So this is going to be 1 plus 1. So this is 2 here. And this is minus. So you have 3 plus 7. So this is going to be 10. Okay. Now, if you look at it, I think things are clearing out a little. Here is already 1. Here is already 1. So let's just go. You can do, this is already in what's almost in, we can just go 1 over what's 1 over 2 R3 now. This is 1, 0, minus 1, minus 3. This is 0, 1, 1, 9. And this is 0, 0. This is 1 and what, 5. All right. So you can see now this is 1 here. This is already in what? In row echelon form. This matrix that we have here is already in row echelon form. So if we want to use Gaussian elimination, we can stop here and just take Z to be equals to 1. But now let's proceed. This is row echelon. Let's continue so that we just use Gauss-Jordan, since in question number 4, we use Gaussian elimination. So it means that this is 1, this is 1, this is 1. So we have to take this to 0 again. So this has to go to, these two numbers have to go to 0. Just like here, we have to take this one to 0. Right? Now, to take this to 0, what do? Still row operation. We still have to use the row operation there. And what type of row operation do we need? It's just very simple one. We use R3 plus R1. Yes, this is for the first row because we are fixing row 3 now. So let's write row 3, 0, 0, 1. And here it's 5. So for row 1 now, it's going to be the additive inverse, which is minus 1 is 1. Then for row 2 is going to be minus R3 plus R2. So this is still 1. This is still 0. This is 0. Then minus R3. So you have minus 5. So it will be minus 5. Then minus 3. That is going to be minus 8. Then for this one is, no, I think we're just adding. For row 1, we're just adding. So there is no need for minus. So because it's just R3 plus R1. So you have minus 3 plus 5. So this is going to be 2 here. Yes. But for row 2, that is where we use minus R3 plus R2. So it's going to be, this will be 0. This will still be 1. And this is going to be 0. And now you have minus R3. So it's going to be minus 5 plus 9, which is 4. So this is what? This is in row reduced echelon. Row echelon. So it means by what? By Gauss-Jordan, we just get our values directly. So by Gauss-Jordan, it means that what's xz, or you can just x is equals to 2, y is equals to 4, and what? Z is equals to 5. So the solution sets is 2, 4, and 5. And now if you look at it, what is the solution? The solution is actually UVW, according to what they said. And you need the product. So you take this as your U, you take this as your V, you take this as the W. So therefore UVW, it's simply 2 times 4 times 5. And this should give us what? 40. All right, so that's the end for the video series for 11.1. If you have any question, Leave it in the comment section. If you are not yet to subscribe to my channel, kindly do that. Also share this video with your friends. Thank you for watching.